Alan, really brilliant to have you with us today. Thank you so much for joining us. For the sake of our audience who don't know you, who's Alan? How did you get into this? What's a little bit about you and what you do?
Okay, so thank you very much for the invitation to join you today. It's really good to be here. So I'm Alan Puttock. I'm a lecturer in nature-based solutions at the University of Exeter. My background's been always about, probably for the last 10 years or so, which is my career in academia, thinking about how we manage our landscapes to more resiliently tackle the challenges of hydrological extremes, so flooding, drought. We do face those flooding pressures, those drought pressures, those water quality pressures. How can we look at more natural ways of tackling those challenges?
Brilliant. How did this project start? I mean, it's not something you hear about every day.
About 10 to 15 years ago, we were working with Devon Wildlife Trust actually on another project looking at these rough grasslands. Are they maintaining flows during dry periods, giving water quality improvements, giving natural flood management improvements in terms of reducing peak flows and such. So I was working with Devon Wildlife Trust on this project, and they had also had one of the first small beaver enclosures in Britain at the time. So again, I started monitoring this beaver enclosure. It was absolutely fascinating to me, working on all these sites where we're the engineer, we're restoring landscapes to try and improve this hydrological function. But here there was this crazy animal doing it for us. So this got me started. I was monitoring the water quality of this small beaver enclosure, how much water was entering, how much water was leaving, the water stored within this beaver site. And that just, one thing's led to the other. And now, I kind of work on multiple beaver projects across the country, multiple projects with partners such as the Environment Agency, Devon County Council on projects such as the Devon Resilience Innovation Project. And all these projects are looking at how we can use nature-based solutions, natural flood management approaches to increasing the resilience of our systems for hydrological extremes.
It was, in fact, the Devon Resilience Innovation Project that caught my eye, because in there you presented quantitative evidence showing clearly that beaver-created wetlands reduce peak flows by an average of 30%, if I remember well. And they also improved the water quality that you've been monitoring by filtering out nitrogen, phosphorus, and suspended solids. So this is a viable, quantitative piece of evidence that shows that nature-based solutions can complement grey infrastructure. Can you tell us a little bit more about that specific project and how we can use that evidence to increase the use of nature-based solutions going forward?
Absolutely. So on the initial site we were working at in Devon, Beavers had created a series of 13 dams in this 2-hectare site. That was storing around 1 million litres of water, but also kind of pushing water sideways into the landscape in terms of high flow periods. Results of that site showed that during storm flows, we were seeing peak flows reduced by around 30%, but also the lag time between the rain event starting and seeing that flood response peak. That was also being slowed by around 30%, or the results seemed to come out around 30%. So suddenly, because of these 13 dams, this increased in roughness within the site, water was being slowed within the site. And again, not only were you seeing that flood peak being reduced, but also, pushed back. At the same time, we had water quality samples looking at the water entering the site from an agriculturally dominated catchment with high suspended sediment loads, high nutrient loads. Below the beaver site, we're seeing significant reductions in suspended sediment, essentially clearer water coming out of the site. We had these amazing photos of water bottles with dirty water entering the site, much clearer water leaving the site, but also that nitrates, phosphates, etc., being significantly reduced below the beaver site. And we put that down to a mechanism of essentially water being slowed, as it travels through these dams and depositing nutrient-laden sediments within these beaver sites, so essentially acting as a sink. And we've since done more work. We're able to publish from 4 sites across a range of scales, range of land uses, but also then a whole range of other monitoring sites showing that we do see these significant reductions in peak flows, again coming out on average around 30% peak flow reductions. So we are quite confident now, or very confident, I should say.
The take-home message is that you have hard data that demonstrate that beaver dams can do the work of human-constructed dams under the right circumstances, of course. What would you say would be the take-home message for people in the water industry? How best can we use this information to improve the way we make catchments more resilient?
Absolutely. So again, beavers have been the focus of my research for the last decade or whatever. But I do want to add those caveats. They're not this kind of one silver bullet for all of our problems. But what I think results such as this, and also results from other nature-based solutions and things such as the Devon Resilience Innovation Project have shown, is that nature-based solutions absolutely can be part of a solution. They can complement that traditional hard engineering. They can provide multiple benefits. I wouldn't say it's not without challenges. All these nature-based solutions, including beavers, they do bring unique challenges, and what's right where requires careful consideration. But in the right place, they can be very cost-effective, multi-benefit solutions to many of the water resource challenges we face, and other benefits such as biodiversity crisis as well.
Of course. And of course, all their dams are made out of completely carbon positive or carbon neutral materials, unlike concrete.
Absolutely, 100%. And we've shown in some of our research as well that they can significantly trap sediment, and also obviously very organic matter rich sediment, and act as a carbon sink there too.
Amazing. I understand we've got some resources available from your publications that we can share with the audience. Alan, thank you so much for joining us. I love your project, and I'm insanely jealous that you get to do it.
Oh, thank you so much.